back to our series on quadratic functions. And in this second video, we're going to talk about expanding binomials. This should be a bit of a review. Just want to make sure that you have your distributive law intact and you're able to expand binomials accurately and efficiently. So let's talk about the distributive law just quickly. And I'm going to start by introducing to you something called the perfect square, because it's a really nice way to just give an example of the distributive law. So the perfect square is something that's a plus b squared. It's perfect because it's something times by itself. Now just recall that we are expanding binomials. So it's a binomial because it has two terms. Like bicycle has two wheels. So a binomial, we can expand trinomials and move on beyond there. We're not going to worry about that in this topic, but obviously the rules are pretty much the same. So the perfect square expansion looks like this. A plus b times by a plus b, and the distributive law allows us to take this first bracket and break it up into a times a plus b times a plus b. So each term in that first bracket is multiplied by the second bracket. And now we can expand each bracket separately. We get a squared plus ab plus ba plus b squared. ab and ba are equivalent terms, so we get a squared plus 2ab plus b squared. Note, here's a real indication, of course, that a plus b squared does not equal a squared plus b squared. And be careful not to fall into that pitfall. But there's our perfect square and our first example of expanding double brackets or binomials. Let's look at a second example, and again, a very specific example. So this is called the difference of two squares. Now, I can't really tell you why yet, but once we've done the expansion, I'll show you. The expansion is typically a minus b times by a plus b. So quite similar to the first one, but only slightly different. And now I can write this down as a, so I'm going to distribute the a minus b, a times a plus b minus b times a plus b, and a times a gives me a squared plus ab minus ba minus b squared. You'll note here that this negative has continued to follow through the question. It remains with that b. And this gives me a squared plus ab minus b squared. The two central terms there will cancel out with each other, and it gives us a squared minus b squared. And so there's our expansion. Difference of two squares. Well, here's our two squares, and difference means find the gap between them. And to do that, we do a subtraction. So difference of two squares, because it's one square number, subtract a second square number. Let's have a look at a third example. And this one's not a particular type of example. It's quite a simple quadratic though. X plus 2, x minus 3. Distribute the first bracket to give us x minus 3 plus 2, x minus 3, and then expand and simplify. X squared minus 3x is the first bracket expanded. 2x minus 6 is the second bracket expanded. Usually you'll find that these two central terms will combine together, particularly when we're dealing specifically with quadratics within this topic. So we get our quadratic term x squared, then we get our remaining linear term, negative 3x plus 2x is negative x, and minus 6. And so there's our simplified quadratic expansion. And last of all, we'll do one more example. 3y minus 5 times by 2y plus 7. So again, we distribute the first bracket. It doesn't have to be the first bracket, but it's just a nice little pattern I like to follow. So 3y times by 2y plus 7 minus 5 times by 2y plus 7. And 3y times 2y gives us 6y squared plus 21y minus 10y in the second bracket minus 35. And now I can simplify that to give me 6y squared 21y negative 10y give me plus 11y minus 35. So there you have it, binomial expansion. Keep an eye that you look to simplify, and often there will be opportunities to simplify. Be very careful with your negatives. And also, if you've learned this topic in the past, you may have learned some special rules. So there is methods involving doing crab claws, like this. And you can see the crab claw there, and that's just a method to do it. There's a method called FOIL, which is front, outside, inside, last. And that works quite well. And there's some other methods floating around there. But you have to be a little bit aware that those methods do break down once you get beyond binomials. So it's really good to understand this law here, the distributive law. That will always work. So if you can start building that understanding, you'll find as you move forward onto, say, cubes or trinomials, you'll be able to apply that understanding to more complex questions.